Hello, this is Eric Lee again, and I finally found some time to make my video on time and what it is. And yeah, it's a pretty big, complicated subject, so I wanted to kind of put all my, ducks in line and, dot all the I's and cross all the T's, as they say. Um, and I didn't want to have you guys sitting out there saying, did you check off that box where, it says crazy, and check off the box where it says he's full of it. And then did you, oh yeah, check off the box where it says stupid. So, it's kind of a thing I got from like George Carlin. I mean, he's this hilarious comedian, as you know, no longer with us, sorted mist. But he does this whole thing about, stupid people. And I thought it was one of the most hilarious stand ups he did. But anyway, I didn't want to sound like a complete fool, which I may already be doing, but I'm just going to go with it. Uh, and if you remember the last time, I think it was actually 2 videos ago, I said that when um, the Big Bang occurred, it went from basically a positive charged state of energy to um, a negative state, and whether it came through a permeable like uh, dimensional membrane, or if it emerged from smaller particles, it really doesn't matter. It's just going from one state to another. All these particles just erupted, and my theory is that not only did this Big Bang occur and almost simultaneously, maybe within the 383,000 uh, years of its first intense the CMB creation, radiation creating atmosphere that the universe was in. I don't mean atmosphere as in I mean the state that which it was in. It was extremely hot, and I think other simultaneous smaller emergences could have happened. Where's my pen that I usually draw? But I think I explained it already, so I don't need to be redundant to draw that again. So, in other words, they say, where is it? Our universe is 93 billion years, light years across, and basically, um, you know, uh, before it was 93 billion years across, things were forming at the edges of the universe, even, or maybe even beyond. Maybe there's things beyond the 93 billion years. This is the perceivable universe. Remember that. So, they just sent a new telescope up there, and there's all kinds of sensors they're sending up there, or probes, I should say, and they might find that our universe is even larger than 93 billion light years across. But anyway, this notion that I put forth, that there was a spin or like a rotation, because you find that in every you anywhere in the universe. The galaxies are in rotation. Well, most of them are, and you find hurricanes have rotation. You have the Earth, which has rotation. I mean, and I explained the rotation of these planetary bodies as probably some kind of quantum tunneling was occurring, which was another process of high pressure particles going and being compressed by gravity, and being squeezed through the very core, the very absolute center of this core of this planet. You know, and it's causing this like rotational momentum to occur as a result of quantum tunneling. And it says right here on the this is a book, by the way. It's called The Scientist. I think it's from the 70s, and it's a very interesting book about science. And it says the seemingly casual, meaningless jumble of jottings is a major document of science because of the p-violated notation, which I have no idea what they're talking about. P-violated notation, right center. I guess it's right here, if my finger pointed that correctly. The Nobel Prize winning work of the physicists Sung Dao Lee and Chen-Ning Yang, take it they were Chinese, and it upset the law of conservation of parity, which had assumed the symmetry of the universe and suggested instead that space has a kind of twist. So basically, you know, I mean, when I just found this, I was digging through my whole, like, you know, library of books, and I just happened to be leafing through this, and I found this bit of information, and I was like, oh, isn't that strange? I just predicted that the universe could have, as a whole, some sort of rotation to it, and here we find that two Nobel laureates have predicted that the universe has some sort of a twist. But anyway, just keep that in mind, because it pertains to what I'm going to get at. And then another thing I want to mention is like an interview I saw just recently. This was like just a matter of a few couple nights ago, and it was between Sir Roger Penrose and the very famous Jordan Peterson. I think he's a psychologist, a PhD psychologist, or I don't know what his PhD is exactly, but very famous. I watch his videos all the time, and geez, I don't even know his credentials exactly. But anyway, excuse me for that. But this Sir Roger Penrose is a very preeminent physicist. He has some unique perspective on the Big Bang. He has a slightly different, or a very different view from what his own words were, and he was knighted, obviously because he's Sir Roger Penrose, by the Queen of England for his I think he has like 3 PhDs, and one is theoretical physics, and theoretical mathematics, and got the other one, mathematics. Oh, excuse me, I just had a brain concoction. But anyway, he's just a genius, and all my respects to these gentlemen, because they pose some really interesting questions. But when Jordan Peterson, in his very like keen mind, and he's a genius in his own right, I believe, he posed a question like, is there a universal time? And it kind of surprised me that Sir Roger Penrose was like, no, there's no such thing as a universal time, because you have all these different time dilation areas going on in the universe, and then he explains like the classical picture of two people crossing the street, and then a supernova goes off in one part of the universe, and like who sees it first, and this and that. But I was like, wait a minute, really, is that really the proper perspective to view, to say that there's no universal time? Because that's just a matter of just perceiving, when the light or information reaches you. It's almost like the perception of a light itself. It's depends on your locality. So I was like, well, I think I beg to differ on that, because for one thing, I can bring up some very solid scientific examples. Like, okay, we have the solar system, and then we have the sun, we have the earth, and then let's say we send a guy to Mars, which is over here, and okay, what everybody does on here is going on the planet Earth. And by the way, the planet Earth has what? How many subdivisions of its own time? But they're all pretty much at the same rate. I'm kind of like pointing out there's like differences that we just kind of arbitrarily make depending on where we are. And this is what I'm getting at. It's about where we are in the universe, sure, but does that really even matter ultimately? Because I do feel there's a universal time going on. I'll get further into this. So basically, you have an astronaut on Mars, and then you have the guys waiting at Goddard or someplace like the Houston, and everything is going on pretty much. If you could see both sides of the spectrum, like what was happening on Earth as well as Mars, then basically everything would be going on at the same time. And now if you just got tunnel vision and said, well, hey, let's just look at it from our own perspective, well, then of course there's time dilation going on. The speed of light, it changes your perspective of what time really is. But that's really just an illusion, isn't it? Because gravity gravity again comes into play. And what gravity is like, okay, so when the Big Bang happened and we have this universe, it's just 93 billion light years across, as far as at this moment, before they find something outside of this 93 billion light years across. You've got all these galaxies, like just billions of them. I mean, just billions of galaxies, billions, hundreds of billion, trillions of stars. I don't know even, it doesn't even matter what the numbers are. But I mean, they're just like sand in this humongous universe. And it doesn't even matter if you believe in a finite universe or even the shape of the universe, and I'll explain that in a minute too. But basically, in my perspective, I think that there is a basic shape to the universe, and it's roughly spherical, and there's probably a slight wobble to it, but for now, you'll see what I'm getting at. I mean, not for now, but I'm kind of breaking up my sentences into these crazy. Oh my goodness! Like my brain is everywhere right now because it's just too much information. But anyway, excuse me for that. But okay, let me settle down here. So basically, you've got all these stars and galaxies just everywhere. And they each have their gravitational field, and they each have their own time dilation. For instance, like, okay, this galaxy is on its own time over here, and the clock reads, this rate, and the hands could be moving at like some crazy speed because it has a very strong gravitational field or distortion, and it just going, just crazy. It's like a black hole, and then over here you have another giant gravitational field, time dilation going on there. Everywhere so everywhere, just like Sir Roger Penrose stated, these are all separate times, and these are all. It's not, in his words, he doesn't believe that there is a universal time. But like I said, I have a whole different perspective on that, because when the Big Bang happened, you must understand, we consider this our one perceivable whole universe, and is dictated by the law of gravity. And no matter what the differences are between time dilation uh, and the rate of this, we still have entropy going on. And actually, I should have like studied the rate of entropy for. Is it a constant, or does it vary according to how dense the planet is, or but it may be a constant. I'm not certain on that. But gravity is pretty much a law that the entire universe has to obey, and basically, in general, let's say. I mean, there could be certain very special exceptions, but the whole universe, as we know, operates on one law of gravity. So that's where I was like, well, there has to be a universal time. And if this is a finite universe, and it's 93 billion light years across, yeah, even if we were at the edge of the universe, it would appear like any other part of the universe. And it's interesting. Also, I want to throw in there used to be a series hosted by Morgan Freeman. I used to really love that series. It was all about physics. And he said that some physicists do believe that there's a finite universe, but it's so huge, and if that were so, then we would actually perceive more stars in the universe than there actually were, due to gravitational lensing. And what I gather from that is, I think he said it too. He said that basically the edges of the universe would appear almost flat because of just how the circumference is so huge. And then when you have this flatness, you would bounce the images. It's sort of like putting two mirrors face to face. I don't know how many of you have tried that trick. You actually see infinity. It goes on forever and ever and ever. Because the image, the light bounces back and forth to infinity, and it's a pretty cool trick to demonstrate how infinity works, and the math, I guess you can call that theoretical math and whatnot, because not all math is absolutely concrete. But anyway, you get what I'm getting at. So basically, and if there's a spin to this universe, that also would be kind of a measurement of time, and I have this part in my Pinterest. It's called "Time is Faster Than the Speed of Light." If you could imagine, if this rotation of our physical universe is occurring, as was implied by the Nobel laureates, and there's a twist, well, just one fraction of this movement, would beat out any speed of light. And it could be even contributing to all the maybe it's centrifugal force to induce this redshift effect to kind of make all the heavenly bodies move away or the galaxies, I should say, and the stars move away from each other. Yeah, I'm trying to talk as fast as I can with all these crazy ideas in my head. And then I have to pause the video for a second. Get my thoughts. Okay, so I was saying about the rotation of the universe, and then how there is a universal time. And actually, in quantum physics, I believe it seemed to me like they do believe that there is a universal time, if I'm not mistaken in their implications, because they said that time. I thought the same exact thing like years before. They actually saw a video. They kind of beat me to the punch making this video, but they're more qualified to, of course, make this video because they're all PhD physicists, and basically I'm a couch physicist. But they said that it's sort of like frames per second in like a photography or filming, and like high-speed cameras can do now something like crazy. I think they said it's like 1 million frames per second to even catch like every moment of like a projectile, like a bullet, or just crazy fast objects, and see every detail of it, and that's just quite just unbelievable. But anyway, the quantum theorists, they said that I'm sorry, not the quantum theorists, the quantum gravity theorists. I'm sorry. They said that the universe is each like frame. If you want to take a sliver of like time, or even like let's say I took this book and had like every instance of like entropy, gravity, everything that was occurring in the universe, and I drew it. I was like this godlike being or alien, and I was able to draw each and everything on one page, and I would just flip through it, just in this crazy fashion. They said that each frame is the like one Planck length apart. So basically, it's like so smooth of a transition from one state to another, and I define like time as like the existence of matter and all the processes that occur in the entire universe at the same time, and you take a snapshot of it in just that moment, and that's one moment of time. So that's a very interesting thing that they proposed. What else? Entropy. Entropy, they said, is what causes time to flow in one direction. And when I was a kid, I had this science teacher. He said, if you put on this table, this is a table, this book, basically all the atoms in this book, if you left it there for like 1 billion years, would fall through this table. And sure, I mean, the laws of entropy say, well, everything's pretty much going into disorder from order, and basically into decay. So basically, all the paper pages would decay, all the atoms of this, and yeah, sure, all the quantum particles would fall through this table and onto the ground, and then and I would even say that some of it would fall like through the ground. Well, obviously it would, and work its way down to perhaps even the Earth's core. Who knows? But that's entropy explained simply, and they call this when it's uh, uh, low entropy. There's more order to matter. It's in an ordered state. But when it like decays and it just goes into like this pile of ash or pile of like um, rotten paper and just whatever, that's called high entropy. And so according to physicists, that travels only in one direction, which is why time travels in one direction. But it could also even have to do with the rotation of the universe. But then maybe not. I mean, that's just kind of something that I just kind of thought up. But if there's a wobble, and then you could have it flipping another way. I mean, like the spin of a electron. It could be spinning in like this direction. It could be spinning in the horizontal direction. I mean, who knows? So, but that makes no difference. Like I said, the shape of the universe, it's not that intrinsic in the passage of time or universal time. But I do disagree with that all these times are just separate. Like according to a certain physicist, preeminent physicist, and everybody has their own spin. I mean, it's every physicist seems to have their own take on what's happening at the quantum level, especially. General relativity has been proven time and time again, so they don't have any too much discrepancies. But at the quantum scales, they seem to have like differing opinions. And another thing was like in this interview, they discussed the probabilities of quantum particles. Yes, so it was actually Einstein, Schrodinger, and Dirac believed that quantum mechanics is incomplete, and I believe it was Schrodinger with the was the cat dead or alive, or was it Dirac? Oh my goodness, I'm kind of maybe mixing that, but it was one of these two guys, and he kind of was making fun of quantum mechanics because he said it all depended on the observer as to whether like if you stick a cat in a box. I don't know if I can even explain this correctly because it's a weird concept. It all depends on the basically, I guess, when you pull the cat out of the box, and it's your observation that makes the cat dead or alive. It just basically they were saying that if you take a device and you take it, and you measure a particle, and you try to take Schrodinger's equation, which states that all matter, like at the quantum level, if you have an equation as to where it is today, you can predict where it's going to be tomorrow. But when they actually took a measurement of this quantum system or particle, they found out that it didn't fit into his equation at all, and that they got the answer came out to more probabilities of where they could be. And so it just was just kind of kind of crazy in that it didn't fit Schrodinger's equation, which actually is valid, but the result of what they get when they measure it is like, can be this or that, or it can be in two halves. It can be, all over the place, and physicists to this day aren't quite sure why that occurs. But I think I have a very great idea why that occurs, because Sir Roger Penrose um, himself says in this interview, these quantum particles, they have no sense of time. In other words, I said in one of my earlier videos that these particles, they don't follow any time, so they exist in their own kind of multiverse where time doesn't exist. And if you could imagine, if you were on like in this realm, and I don't know if you watched the movie Ant-Man from Marvel, Dr. Pym, who created the suit for Ant-Man, he says, if you shrink down to a certain level, you won't be able to come back because you're going to enter a realm where time doesn't exist as we know it. And basically, it's a place where just time just doesn't exist. And if you could imagine yourself as a being, which probably you would have to be a being of like pure energy, or even if you could stay in your human state, could you imagine you could be in all places at one time, or you could be, in two places at one time? You get what I'm saying. It just, there would be no order to any sense of like causality. Like, you start here, and then, you took 5 steps to be over here. There would be nothing like that. You could dictate, like, even maybe you could perceive the universe as just one whole cylindrical time, events of time, and you could just point at a specific a place and time, and just observe it. Who knows? I mean, this is getting into the metaphysical, but you get what I'm saying with these particles. I think that's what they're running into, and this is, I think, not only a truthful scientific theory on my part, but it's been observed that, I mean, Sir Roger Penrose said it himself. These particles, they don't have time, and that's what I said before I watched his video. So we both have the same view on that, which is kind of astounding. And that, like I said, I'm just a couch physicist, and I was kind of like, yeah, okay, you got it, and. So yeah, that's why it just becomes this weird a world of quantum mechanics where they think it's incomplete. It's not a matter of being necessarily incomplete in that sense when it comes to Schrodinger's equation. It's just that it doesn't work in the way that we expect through our time, Earth time, or our universe's time. It's just these quantum particles, just they can do pretty much what I just stated, and that's why we observe it as probabilities. So I hope I kind of explained in certain ways of what I was talking about. If I missed anything in my head, maybe I'll do a part 2 on this. But yeah, it's pretty exhausting, and yeah, I totally understand why this one physicist I watched, it's a lady from MIT, even she's like, wow, I don't understand some of this stuff, and it just gives me a headache. And she has a PhD from MIT, and I watch her YouTube channel, and she's very insightful, fascinating lady also. And again, keep a sense of humor, and have a good day, and I'll see you in the next video. Thank you for listening to my crazy crazy explanation here, or ramblings. Thank you very much.